Welcome to part 2 of my November 2018 Maths Higher Paper 2 walkthrough. This is question 7, question 1 to 6 from a separate video. Okay, in this question, you've got to do a bit of OCW, so just a couple of words here and there to say what you're doing. We've got a perimeter of a square is 76.4 metres. Well, it's the square, so all four sides are the same. So if we put something along the lines of one side equals 76.4 divided by 4, one side of the square is equal to 19.1 metres. It's not an essay, it's just being neat and tidy and saying what you're doing. To find the diagonal of the square then, we've got 19.1, 19.1, the diagonal is obviously some Pythagoras now. Doesn't say it explicitly, but it's going to be the diagonal of a square. So this is now the square root of 19.1 squared plus 19.1 squared. You should get a final answer of 27 metres for the diagonal after you square root it. Okay, 726 point something before you square root. Okay, and as long as it's neat and tidy and you've said what you're doing, jobs are good. Right, number 8. Probability tree. Okay, there's quite a lot of branches on this. Not a huge amount mathematically to do though. Easiest branch to work out. Remember these two branches got to add up to 1. So not on a Saturday must be 0.92. Okay. We've got 0.15 and 0.45 for plane and train. That adds up to 0.6. So car must be 0.4. And then, because it says travelling on a day is independent of what day it's held, that tells us that these values at the bottom are the same as the ones above. They don't change because it's a different day. Okay, independent means not affected by. So that's going to get you a couple of marks already just for filling in the tree. Then we've got a meeting is chosen at random. Calculate the probability that the meeting is held on a Saturday and that Alwina travels by plane or by car. So we can do Saturday and plane or Saturday and car. So Saturday and plane or Saturday and car. It's probably the most straightforward way of doing it. So that's times in to begin with for your AND rule. 0.08. 0.08 for Saturday times plane, which is 0.15. And then add 0.08 for Saturday times car, which is 0.4. And your final answer should come out as 0.044 as the total probability of either occurring. Question 9. We've got right angle triangles, we've got angles and sides. This is trigonometry then. So part A, calculate the size of angle X. So this is looking at the top triangle. That's our opposite, that's our adjacent. This is a tan question. So tan x equals O over A, so 6.4 over 8.2. If you want to calculate x, you'll have to do tan minus 1. So x equals tan minus 1 in brackets, 6.4 over 8.2. That gives us an angle of 37.9 degrees or 38 degrees. If I say 37.9 degrees. Part B, calculate the length of AQ. Okay, so to do that then, we're going to have to put in the missing angle on the bottom triangle, and it's small, but there is a little right angle symbol in there. We've just calculated that this top angle is 37.9, I'll call it 38. So our bottom angle, if it's got to make a right angle, must be 52. We've got the opposite side already. We're supposed to be working out A to Q, which is the hypotenuse. So this is a sine question now. So sine 52 equals O over H, so 7.9 over H. When you're working out H, because H is on the bottom, you've got to do a little bit of swapping around. Remember, H is the longest side. So H is 7.9 over sine 52, which comes out as pretty much bang on 10 centimetres, depending on how accurately you worked from the question above. Okay. Question 10. A googol is the number 1 times 10 to the power of 100. Calculate the value that is 90% of that. Okay. Well, 10% of it you would divide by 10, and when you do that, the power will drop by 1. So that would be 1 times 10 to the power of 99. That would be 10%. So 10% of the number would be 1 times 10 to the power of 99, divided by 10, drop the power. So 90% is 9 times bigger than that, so 9 times 10 to the power of 99. That's a bit of an odd question, that one. Question 11. We've just got to sketch a tan graph in the range of minus 180 to plus 180. Doesn't come up often, a tan graph. Tan graph is the one which is a little bit unusual. So there are asymptotes at 90 degrees and minus 90 degrees. If you type in tan 90 into a calculator, you'll get an error. The graph doesn't really exist at 90 degrees and minus 90 degrees. An asymptote means it never touches. Okay, we go up there and down there. It reappears down there and goes back to 0 at 180, and from here it comes down. It's a little bit like Pac-Man. It disappears off the top and then reappears at the bottom. Okay, so make sure you learn your graphs. Sine and cos, I would say, are probably more likely to come up, and then you could obviously do sort of multiple solutions from those graphs. Okay, moving on. Question 12. Calculate the total surface area of a solid hemisphere with a base radius of 29 centimetres. Okay. So you've got the surface area for a sphere on the front cover. So for a whole sphere, it's 4 pi r squared. So for a hemisphere, the curved surface area is 2 pi r squared. 2 pi r squared. So that's 2 times pi times 29 squared. It's solid though, so it has a lid. It's not a bowl. And that's a circle, so there's another pi r squared there. So you've got to do another pi times 29 squared, so that's 3 of them all together. You should get about, as a final answer, 7,922 centimetres squared. Okay, 0.3 if you want to put a decimal point on, but that's just using formulas off the front cover, halving the surface area of a sphere formula, and not forgetting to add on an extra pi r squared for the lid. Okay. Question 13. Fully factorise the expression c cubed minus cd squared. Now it's 3 marks, so it's not going to be as simple as just what have they got in common, which is a c, and saying c squared minus d squared, not for 3 marks. Okay, so it's question 13, it's got to be more to it than that. You've got a spot there that in the brackets what you've been left with is difference of 2 squares. Okay, something squared, take away something else squared. And the shortcut for factorising those then is you have 1 plus bracket and 1 minus bracket, and you just square root each term. So you get a c in both brackets and you get a d in both brackets. Okay, and then part B, they like these. There's a long way and a short way. If I talk you through the short way first, in normal factorising, if you've got something like this, to to finish off the question, you take the parts from outside the brackets and you would put them together. So your final answer there would be 5x plus 3, which is what we call the loose terms, and then x minus 1. Okay. And we've got something that looks a little bit like that in this question, except one of the brackets has been squared. But if I can make it look like what I've got here in red, I can just factorise it quite quickly. So, if I wrote this out as 5e minus 1, e minus 1, plus 3e minus 1, and I just expand this first one, so 5e minus 5 brackets e minus 1, plus 3e minus 1. Let me move that other stuff down out of the way. Whoops. Let me do this. Sort of. No. Okay. Now I've got loose terms out in front. So my loose terms are there and there. So that would go into a bracket. So 5e minus 5 plus the other 3, close the bracket, and then e minus 1, which gives you actually 5e minus 2 e minus 1. Okay, so that's your final answer. Let's just put a box around that so it's not in the way. The alternative is you have to expand everything out, form a quadratic, and then refactorise from scratch, which is going to take a little while, and it's only worth 2 marks. Okay, so if you can understand what I've just done there, trying to get loose terms in front of a common bracket, that is the quickest method. It comes up a few times, so if you look through your past papers, you'll see a few of those might be worth a little look at for 2 marks. Okay. Okay, question 14 is what looks like 3D Pythagoras. There's no angles given in the question. There's no angles I've been asked to find out. So on this question, we want to get A to G. To do that, we're going to need to do another triangle, a different triangle first. Since we've got a 7 and a 3 on the base here, I think what I would like to do is go across there to start with and work out E to G first. Okay, so if I redraw that sort of normally, we've got a 7 there, we've got a right angle in the corner, and we've got a 3 there. So it's going to be the square root of 7 squared plus 3 squared, so that's the square root of 58, which is roughly 7.61. Okay, probably best to leave that on your screen. So we've got 7.61 there, dot, dot, dot. And then I can do the sort of the upright triangle, which goes along there and has A to G in it. So if I redraw that one, we've got A at the top, G down the bottom. We've known that that's 5 all along. We've got our 7.61. And so it's the square root of, and this is why it was best to leave it on a calculator, because you can use the answer key to type this in, 7.61 dot, dot, dot squared plus 5 squared. Okay, that is the square root of 83. Your final answer for A to G is 9.11 centimetres. Okay, so if you have to work in 3D, don't, basically. Try and spot a 2D triangle that you can work out, and then see if that helps you to make it, and then another 2D triangle to get to the size you're after in the question. So we've ended up with 9.11 for A to G, and we'll carry on from question 15 in the next video.